Hello, I'm Dr. Levon Hayrapetyan, a business professor at Houston Baptist University. And in this short demo, I will show you how to calculate Jaccard's coefficient, which is another measure of similarity between observations. Let me enlarge my slides. So what we did in one of my previous videos, we discussed how we can calculate similarity between two observations when the values of variables are zeros and ones, which means variables are categorical variables encoded with zeros and ones. And the method which we learned called matching coefficient, and the way we calculated it, we just calculated how many variables are matching, so how many matching zeros we have and how many matching ones we have. We calculate total matching number of matches and divide it by total number of variables, and that is called the matching coefficient. One weakness of this matching coefficient is that if two observations have zeros, then for the same variable, then it will be treated as those variables are similar, which is not true in many real life situations. So that's why in order to avoid misstating similarity due to absence of which features, which means zeros, a similarity measure, which this measure is called Jaccard coefficient, it will just not count matching zeros, as simple as that. So it will ignore matching zeros. So this is the formula how we will calculate Jaccard's coefficient. So we will calculate total number of matching non-zero values, and then we will divide it by the difference of total number of variables minus total number of matching zeros. Let me show this in Excel. So this is what we did in one of my previous videos when we're calculating matching coefficients. Now we will calculate Jaccard coefficients. These are the same observations. So the essence is for Jaccard coefficients, we will only consider matching on ones. And when there is a match on 0, 0, 0, 0, 0, this we will ignore them. So how to do that? So in order to do that, first I will cut, there are several ways to do that, but I will do this way. I will calculate, in order to figure out which type of match we have, I will just add these two numbers. Let me do that. Sum what happened? Equals sum and these two. And we got 2. Then I'll copy this across. So what you can see from here, we have a matching ones, and here you got 2. There is no match, we got 1. There is match, but on zeros, then there is 0, which means just looking at these numbers, we can judge which type of match did we have. So here we have match on ones. If it's 2, if it's 1, then there is no match at all. If it's 0, then it's match on zeros. Now what I will do is I will calculate, in order to implement this formula, I need number of matches on non-zeros, number of matches on zeros, and total number of variables. So here, let's calculate total number of variables. Last time I showed you how we can use count function and to calculate how many variables each observation have. In our case, it's 10. Now we want to calculate how many non-zero matching do we have. In our case, we have 2 of them, but how we can, this is a very small data set, so we can visually see it, but we would like to come up with the formula which will calculate correctly. So the logic is that whenever we have to calculate how many 2's do we have in this range. And for that, Excel has a function is called COUNTIF. COUNTIF, and you specify the range where we will count, and then you will specify we'll count only those which are equal to 2. That's what we want to calculate, right? And we got exactly 3. This is 1, this is 2, this is 3. This is how we calculate matching non-zero values. With the same logic, we will calculate matching 0 values. In this case, we will count how many zeros we have. It will be again countif, and the range is this, comma, equals 0. Now I have all values which are needed to calculate Jaccard's coefficient. And what I will do here, I will just implement this formula in Excel. Equals, excuse me, number of variables with matching non-zeros will be this. Divided by, we'll divide by the difference, that's why I will put in parentheses. Total number of variables, which is this, minus a number of matching zeros. This. So this will be Jaccard's coefficient for these two observations when we are comparing, or measure of similarity between these two observations when Jaccard's coefficient is used as a measure of similarity. So what we learned here, we learned 2 measures of similarities when our variable values are zeros and ones. One is matching coefficient, and we learned how to do that, and the other one is Jaccard coefficient. We learned how to do that. This concludes my short video. Bye-bye.